Were you expecting that level of attention? And from your perspective, what was that moment like?
Yeah, well, it is. And by the way, you're doing just great as a software engineer, and I obviously I think that will continue. I mean, we're all engineers ourselves, and we're certainly excited for our. I actually think we're getting into really the golden era of software engineering. But it was great. I mean, obviously we were not even close. I mean, we hoped the launch would go well.
If the implementation layer is fully taken away, what does that mean for software engineering as a career?
Yeah, and I mean, I think the answer is actually absolutely yes. And I think the reason that is because, for as long as it's us using the computers rather than the other way around, and hopefully it's that way for some time, it's going to be up to us to decide what to do, right? And I think actually we call it computer science, we call it programming, we call it software engineering. But at the core, like the thing that it's really about is about just being able to tell your computer what you want it to do.
Welcome to the Why You Should Join podcast, where every 2 weeks we sit down with the founders of some of the most notable hypergrowth startups. As always, my name is Usman. I am one of the co-authors of the Why You Should Join newsletter, and I'm also the host of this podcast. Today's company, Cognition, is building the world's first AI software engineer. Their flagship product, Devin, is an AI agent designed to autonomously carry out complex software development tasks end to end. The company was founded in November of 2023. They've raised over $300 million to date with investors including Founders Fund, Koshala Ventures, Elad Gil, Conviction, and more. Not to mention, their most recent fundraise brought the company's valuation to a whopping $4 billion. I'm super excited to be chatting with Scott Wu, the company's CEO and co-founder. Scott, thanks for doing this.
Yeah, thank you so much for having me on.
Absolutely. Well, let's dive right into it. So I know you guys had a demo that did quite the rounds, so I suspect just about everyone here has seen what you guys are building, but just in case, to set the stage, for those who are familiar with Devin, haven't used it or seen it, do you mind giving a quick run through of what exactly it is that you've built?
Yeah, for sure. So we're building Devin. It's a fully autonomous AI software engineer. And it's funny saying this now in 2025, because I think when we were saying this in 2023, everyone thought we were kind of crazy. But yeah, I mean, the whole idea of Devin is Devin is a full asynchronous coding agent that can take on full tasks, right? And I think there are a lot of different products out there in code today. The thing that really sets us apart as an AI coding product is that Devin is able to execute on the full end-to-end of the stack, right? And so Devin will not only write code, edit code, and so on, but it'll be able to run the lint itself. It'll run the tests. It'll execute commands. It'll install packages. It'll look at tickets. It'll talk to you in Slack, and basically use all the same tools that a human software engineer would use.
Wow, that's awesome. And we're definitely going to dive into a lot of that very shortly. But while we're on the topic of sort of like the demo video and all that, I was curious, honestly, just personally, I think that demo video and that launch was a little bit of a cultural moment. I think like your guys' launch really sort of broke the chasm between tech Twitter, Silicon Valley bubble, and even had my mom texting me saying, see, I told you should have been a doctor. So, I mean, obviously when you release something, the goal is for it to sort of pop off. But yeah, I'm curious, were you expecting that level of attention? And from your perspective, what was that moment like?
Yeah, well, it is. By the way, you're doing just great as a software engineer. And I obviously, I think that will continue. I mean, we're all engineers ourselves, and, we're certainly excited for our, I actually think we're getting into really the golden era of software engineering. But, it was great. I mean, obviously we were not not even close. I mean, we hoped the launch would go well. We were putting that internally, honestly, for us, it was such a mess. And it was one of my favorite weekends. One of my favorite weekends ever, honestly. The article went out on a Tuesday morning. It went out at 9 a.m. The thing is, it was actually supposed to go out at 6 a.m.
Okay.
It was like a Bloomberg article and everything. But then we had to ask them, like we wrote them last week, like, please, could you just hold, we need like a couple more hours. And, we did need those hours to get to 9 a.m. And it was like, there's the video of me talking at the couch and everything, and then showing what Devin looks like and stuff. And like, dude, we hadn't finished filming that video by like 1 a.m. that night. So there was like, and that's, there's obviously all of the other, there's all of the other content and sharing the demo runs and putting out the blog post and stuff like that. And there was so much to do, and at the time it was all very much just like using every hour as best as we could. I mean, we were a very small team that is still a very small team, and a lot of it was like as you can, I mean, there's just so many things to do, with any launch, right? There's getting our investors or our friends to help out and promote it for us. There's putting together the blog post and really articulating like what we think the future is going to look like. There's getting it out to the initial early users so that they can try it and give their own firsthand feedback of what the product was like. And there was just that, it was a fun couple of days for us. It was like, I mean, we were honestly shocked, to see it.
No, and a little bit of a follow-up on that too, which is, yes, the initial shock must have been pretty insane, but also I think with it came a lot of sort of lingering hype. And obviously hype, I think, is great in some ways. It can tangibly help with, raising capital or hiring or other things. But I think it also brings a little bit of a target on your back. It invites a lot of the skeptics, the critics, and, stuff like that. How has that been sort of, from your experience, kind of navigating all of the media onslaught that came afterwards?
Yeah, for sure. I mean, it's obviously, once you put it out, it's you're not really in control of your own narrative anymore, right? And it's how it is. And we felt this way this entire time, that, for example, that this is going to be amazing for software engineers and the people were going to be able to build way more and do way more. But we were pretty quickly accused, I would say, of basically, of trying to take software engineers' jobs or all of these other sort of things. There's the fear, there was the doubt, the skepticism. There's a lot of these things. And I think for us, it's we obviously do everything we can to just kind of like build a really great product and show the world what it looks like. But I think the biggest kind of the biggest axis that we have control over is just getting the product out there and letting people try it out for themselves. And so the big thing is to kind of just push more and more towards that. And so, in December, just a few months ago, we had our full general availability launch where, anyone could put down a card and just sign up and pay for Devin, and connect their GitHub repo and get started, right? And before then, it was primarily enterprises. But yeah, I mean, it was really exciting, basically, to just get it out there and have everyone see all the full aspects, the good and the bad and everything, and just try it out. And I mean, I think it's very, look, I mean, I think Devin it's certainly not magic, and it does some things very well, some things not so well, and so on. But I think all in all, just letting people try it out and see for themselves what the experience was like was the big thing. And in the last couple months since then, it's been fun to see all these different, a lot of different companies where it's like Devin is now the #1 GitHub contributor at the company, and then posting the GitHub graphs and stuff like that. And I think it's been great, basically, to have it just be much more organic that way.
Yeah. And for folks who maybe are not familiar, Devin is generally available, so people should definitely check it out. And you can do so on their website. But on the point of sort of controlling the narrative, maybe let's dive into that a little bit. Like, sort of, what is the big picture vision here? What is end game for Devin? Is it that just about anyone, no technical background, can sort of come in and take an idea and get a working application in a matter of a few prompts? Or is it a little bit more like, hey, you're an engineer, you do have technical background, but now you sort of have this agentic assistant, or maybe like an army of these interns who you can kind of guide and do work for you?
Yeah, it's much more so the latter today. It's very focused at a technical audience, and it's, practical engineering teams with their existing code bases almost always, right? But that are, figuring out, building new things, fixing issues, doing upgrades, whatever it is, on their code base, and working through that. The way that we kind of think about it is, I think self-driving is a great analogy here, where it's there's been a lot of different phases of self-driving right? Of self-driving cars, right? And it started with automatic shift, and then there was cruise control and so on, right? And I think eventually, in the long run, we're now reaching this point, I'd say, with self-driving, where there comes a point where you actually don't have to have a driver's license at all. You can sit in the back seat and just have it do everything. But up until then, it's obviously still really valuable to know how to drive, right? And I think software engineering is kind of like that, but even there's even a lot more dimensions, right? Where it's kind of like, you might know a lot about front end, but less so about back end. You might know, right? And so what we typically see with Devin is, it's folks who are pretty technical who are using Devin themselves, and it's more like turning the bricklayers into architects, if that makes sense. It's more like turning every engineer into an edge lead and giving you your own team of Devins that you get to work with and assign tasks to. And, they'll ask you questions, or they might need guidance from time to time, but it's basically having your own army that you can work with.
And so that's definitely what it looks like today. But I mean, if you play out that scenario further, and, everyone is sort of the architect, at some point, if the implementation layer is fully taken away, what does that mean for software engineering as a career? Dare I even ask as like an education? Like if you go to school, I went and studied software. What do I study in school now?
Yeah, people ask me this all the time. So should I even really still be studying CS?
Yeah.
And I mean, I think the answer is actually absolutely yes. And I think the reason that is because for as long as it's us using the computers rather than the other way around, and hopefully it's that way for some time, it's going to be up to us to decide what to do, right? And I think actually we call it computer science, we call it programming, we call it software engineering. But at the core, like the thing that it's really about is about just being able to tell your computer what you want it to do, right? And I think what you learn in computer science, for example, in CS classes in school, sure, there's a little bit of understanding this detail, these programming languages or things like that. But by the way, programming languages change all the time. It was Python. It's Python today. It used to be, there's Java, there's C, and there was, assembly and basic stuff before that too, right? And I think in practice, like the core skill I think that really remains, I'd say, is just this base kind of problem solving, right? It's like how do you break down problems and understand things? How do you take a problem and understand, okay, here's exactly what the problem is, and here's what my solution is going to be, and here's how I'm going to build it. How do you understand the model of what's possible to implement and what architectures work and don't work and so on, right? And I kind of think what we're going to get to is a point where using Python feels kind of like using assembly today. I mean, there are some people who do use assembly, right? Especially if you're really relying on clock cycles or whatever it is, you want to peel back the layers of abstraction and really work with the kind of the base gadgets, right? But I think at a high level, I think what happens kind of today is that high level understanding of these layers of abstraction of this is what the computer is doing under the hood, but I'm able to talk with it in a much easier language, is what most programmers are using. And if anything, by the way, there's way more programmers than there were in the age of assembly. People actually don't realize this, but up until around the year 2000, there's actually still fewer than 1 million software engineers, and today there's about 30 million in the world. Yeah, and so it's grown quite a bit, right? And obviously that's despite, or perhaps because of programming getting so much easier, right? Yeah. And I think it's going to be the same thing. I think there will be a point where you don't have to look at the code if you don't want to, and a lot of it is just like interacting with your own product and saying, okay, we should have a new page here that does this and that, and like, by the way, let's track all this information in this form, and what would be really cool is like, all right, let's collect this data and then show it to the user this way and that way, and whatever it is, right? And it's just happening basically, in front of you because you're working with Devin to do that. I think it'll take us some time to get to that future, but I also think that the core problem solving skill and the core thing, I think we'll still call it programming actually, because it will still be this core piece of building software and interactively, being a problem solver. So.
Yeah, that's really interesting. Well, we'll definitely touch on sort of like what it means to be a problem solver and how that kind of shapes up in like sort of the advancements in reasoning models as well. But kind of on this point of, you'll still, software just being abstracted and you'll still be able to use this almost like a no code or AI coding tool. There was this interesting point that I think Bill Gates made. I forget where, it might have been an interview or something like that, where he was sort of talking about how, a lot of these no code, AI coding tools, automation, anything that kind of abstracts away the technical implementation from the developer mostly helps with familiar problems. And they don't necessarily push software development forward in the same way that, say, maybe a new programming paradigm or major infrastructure shift does, which is like, hey, these tools know what already exists and kind of piece that together for you. Do you think Devin sort of fits into that, which is like, hey, this is a final form of like implementing as we know today, or do you think Devin can also kind of drive, these breakthroughs that previous no code or automation tools couldn't?
Yeah, and I mean, Bill is the GOAT, obviously, so he knows a lot more than I do. But what I would say is, I think that's the way I guess I kind of think about it is, it's true, but it's always been a spectrum, and that's kind of how I think about it, right? I think we've kind of always said this, that the human is the one driving, and there's still kind of like a ton, there's execution parts that the computer takes care of, right? And I think that's essentially how that's how humans have always worked with computers, right? But at the same time, what counts as ideation or what counts as core problem solving or what counts as execution, I mean, that's changed a lot. I mean, it used to be the case, for example, just to give a simple example, totally unrelated to AI. It used to be the case that if you wanted to have your own website, then, you had to go host a server, you had to go figure out things with DNS, you had to go set up things. There was no Cloudflare, there was no, I mean, all of these various things, right? And obviously, as time has gone on, we've been able to abstract more and more of it away and get closer and closer to the real meat of just being able to decide what it is that you really want, right? And I think the same is the case here. I think that I mean, in general, in the field, for example, like I think AI has shown its ability to solve some incredibly difficult problems, right? And you could call it pattern matching, but it is. I think there's some really difficult and really involved stuff, right? But I think it's maybe one way to put it is even if all it did was taking care of the 90% of the execution, and so then you have to do the 10% of ideation 10 times more. I mean, that would be enormous. I also think that as time goes on, we will refine our own opinion on what it means to be idea versus execution, right? And you will get to the point where within that 10%, a lot of those things we would think of as kind of like layers that you can decide or that you could abstract away or things like that, right? And we will continue to peel that back, and we'll go from 90 to 99 and 99 to 99.9. But I think that, but yeah, I think humans have always kind of worked with computers in this way, and yet, it is very different, using a computer today or writing software today than it was 20 or 30 years ago. So
yeah. And so I guess kind of the point that you're making here is that, look, hey, no matter how much we abstract, there will still always be the human that's using the computer, and sort of what that results in maybe isn't so easily predictable right now, but the human will be in the driving seat, is like safe to say.
Yeah, exactly. I think folks sometimes say something along the lines of like, oh, there's computers that can't do things that humans can't do, or things. I mean, my computer can do a lot of things that I could do. I can't do. I probably I can't multiply these big numbers or run through all. So I think practically the divide has generally it's always been kind of like a bit more fuzzy of a divide, and I think at a high level it is something like the human is the one directing and coming up with the ideas, and the computer is the one doing the execution. But yeah, I think the border of where what we count as ideas and execution, I think that changes all the time. So
yes, that's a great point. Yeah, and I guess on this kind of introduces like a little bit of like the reasoning models, and I know this is a bit of an unfair question, but playing a little bit of like even like a devil's advocate on this, right? Which is that let's just say these models get great, right? And to the point where, what do you think is there a world that could exist where the human really doesn't have to do much beyond the initial idea even? I know we're talking about like this border of execution versus idea, but even like edge cases or how to improve it or how to optimize it. What if the reasoning model could cover all of that, right? Which is you really just have to have the idea and then the rest is made.
Yeah, no, I mean, it's going to be an interesting few years. What I would say is it is. I think we're about to see in the next 2 or 3 years, the level of magnitude of change that probably took place over the last 40 years in software, where, yeah, I think a lot of these things, we're going to basically like reinvent entire new frameworks and new processes for how we build these things. I think that, I think that there will be a lot of spots where it's going to be an interesting question, basically, of what is possible with AI and what is not possible with AI. And so far we certainly haven't seen any signs of slowing down, which is it's crazy that the things are still going as fast as they are at the level things are at. I think there's a real core of being a creator, which I think is it is what makes humans really unique, I would say, and that is the thing. It might be the case. And by the way, this is the case with technology throughout time. Obviously, we have very different needs today as a society than we did 1,000 years ago, right? But I think that it might be the case, for example, that a lot of these basic things are now provided for us in the future because the technology takes care of itself in certain ways and so on. But I think the innate kind of human passion and the desire to create and to do things, and there will still be a lot of things that are scarce, and there will still be things that have meaning, and I think that I think that'll be more similar than people sometimes portray it as, basically.
Yeah. Well, I guess maybe it's safe to say that Cognition and Devin is not the end of software engineering, maybe even the start of something even huge. And so that's pretty exciting. Yeah.
No, I mean, I agree. And I think it's, again, it just comes back when I think about, you know, all of the products out there that could exist. And one way that I kind of think about it is, there's a tier of products which billions of people today use. I'd be talking about like YouTube, Instagram, TikTok or things like that. And these are incredibly well-made products. I mean, to be honest, it's like, they're streaming you gigabytes of data. Their algorithm is really on point. They never go down. Every single piece of the UX is as intuitive as possible. It's super, super engineered to be, a really great experience, right? And those are really, really well-made products, right? And then, it's kind of like every tier, every order of magnitude you go down, you kind of see the difference in product quality, honestly, right? You go to the products that have like 100 million users out there, right? And then you go to the products that have 10 million users, then 1 million users, and then 100, and then eventually it's like, your local, it's like your community, like school website or something. And it's, it has the address, it has a nice photo of the page, but it's certainly not as polished of a product experience by any means, right? And I think that, to me, it just kind of speaks to how much more there is out there to do with software, right? I mean, I think there are so many other great products to build where it's obviously, I mean, it just doesn't make sense to build right now because it would take months of software engineering time to do that, right? And you can imagine a point where a lot of software is actually built single use. Like that is something I think we'll see in the next few years, which I think is going to be really exciting, where it's software that exists only for a single purpose, and you use it at one time, and then it's done. But I think in general, people talk about Jevons paradox all the time. I think there's nowhere that it's more true than in software. We have always found more and more and more ways that we want to use software in the world.
Absolutely. Yeah, that's awesome. Well, to drill a little bit, I wanted to dive into a little bit of like a more thought experiment kind of side of the podcast, and this is a little bit for our more research inclined audience members. I want to touch on the topic of like maybe even reasoning models, and I have sort of two kind of not very related questions to this, but sort of the first one was, I thought you had a really interesting conversation with, I believe it was the CTO of Together AI, and you guys kind of touched on the topic of specialized models. I'm curious, like, do you see a future where Devin isn't just one general AI software engineer, but instead maybe a collection of these specialized models optimized for its own kind of side of software, development? And if so, would Cognition need to sort of build its own reasoning model to make this happen?
Yeah, so Devin it's a compound AI system, which means that it relies on multiple different models that all work together, basically. But yeah, what I'd say in general with reasoning is it's worth reflecting upon still that RL works. Like it is insane, actually. I think we call this all the last few years the Gen AI era, right? I think there are actually two eras. There's one between 2022 and let's say 6 to 12 months ago, and then there's the one that we're in now, and they're actually quite different eras. I think the previous era was much more about imitation learning, right? It's basically you train a model, you read the entire internet, and then you get something that can talk like the internet, basically, right? Which is a big deal. I mean, it was obviously ChatGPT went crazy, and all of the products, for those couple of years. But I think now we have a totally different paradigm, which I think is a lot closer to how humans think about things, right? Which is reinforcement learning, basically, which is like if you have a very clearly defined set of tasks and you have a clean feedback loop for how you decide if the task was successful or unsuccessful, you can basically have your model try that task over and over and over and try the other tasks and do them all until it's learned how to do all of them very well, right? And it's a very different paradigm. And if you think about what's next, well, some folks would say, that's already AGI or ASI or whatever you want to call it. I think it's, to some extent, it actually kind of is. But I think the main thing that kind of is next, obviously, is what do you teach it, right? What is the benchmark that you train it against? What are the environments that it learns on? And a lot of, I think, what we're going to see over the next little while, actually, is basically this new paradigm where these models are specialized for the tasks that they're trained on, right? If you have a very clear loop of here are the things that I want this to be really good at, and let's say you're building AI for customer service, you're building AI for sales, you're building AI for legal, or whatever space it is, right? If you have like a really clean loop, we're pretty rapidly getting to the point where, in fact, you can just train a model that just gets like 100% on that loop, right? And then the thing that happens, obviously, is that in some sense, the differentiation is actually, what you define as the behaviors and what are the set of things that it uses to make decisions and what tools does it have access to, right? And so I think for us, it's how we've always thought about these things. I think it's, I guess one way to put it is, I think the model, the model training side and the actual product behavior side are just so tightly intertwined where, it's a very different thing to teach someone to be a really great engineer than it is to teach someone to be a really great lawyer. And so that requires a specific training loop, and it requires specific data points to learn on and so on. So.
Yeah. And okay, so I said these questions weren't really related, but I think maybe now they are a little bit more than I even initially assumed, which is, to me, this almost kind of connects to the point of like sort of verifiable reasoning, which is like, okay, if you have Devin and it's capable of, debugging, iterating, learning from its mistakes, one could see it almost be a tool for generating like high quality, like ground truth data or something for a reasoning model, right? Do you think that's possible? It's just like a Devin's usage could generate sort of high quality training data that maybe could be leveraged to build better reasoning models?
Yeah, for sure. So one of the nice things about code, and this is, by the way, I would say, kind of the main reason that code, I think, has been the first to really take off in terms of language model use cases. One of the great things about code is you get to run the code, right? and so, with all these other fields where you might need a human to go review the output, or if you are solving AI for accounting and your feedback loop is you find out a year later that you got audited and that was a bad outcome,
you're in jail. Yeah.
Whereas in code it's basically, you run the code and it gives you the result or it doesn't give you the result, right? And it's obviously that alone is not a perfect thing, but it gives you a much cleaner feedback loop that ties in with everything else in order to make these models learn much faster, right? And so I think there is like a real diff here, and even the way that we do all of our evals, for example, we shared a few posts on basically how we do this and how we run these evals and so on, but a lot of it is very much it's okay, here's a repo and you have to get the repo working, and doing that might involve all sorts of various things that we as engineers know very well, which, you try to run the repo and it turns out you're running the wrong package, it's installed like the wrong version or something. You have to go downgrade the version, and then you have this other port open for this other thing. So, and then you have to go fix this little bug and stuff, and then you run it. But when you get the result, the result is some text or some outcome or something that is not fakeable, right?
Yeah.
And that's the kind of thing that gives you a very tight feedback loop on determining whether or not Devin succeeded on a task. And so that's how that most closely ties in, I would say.
Yeah, absolutely. No, and I'm glad you sort of made a point of this, because I'm sure to you and your team this is like very obvious, but I think for a lot of people, maybe they don't maybe initially sort of think of like that feedback loops allows this specific domain to really skyrocket, and makes me personally very like bullish on things like cognition, which is like you have that feedback loop for data, which is very powerful. I guess now sort of pivoting or segueing into sort of another topic. One of the advice I got, which was like, to be a good podcast host, you kind of have to ask the question that's on everyone's mind, but maybe no one really wants to ask. And this is where we kind of enter into like that little bit more tricky area of, let's say, competitive landscape, right?
Yeah.
I'm curious kind of how you view all of this, which is obviously there's, a good number of teams, some big, some small, kind of working on this AI for code problem. Without sort of having you reveal any trade secrets or anything like that, what do you think is sort of fundamentally different about Cognition's approach? What makes you confident that Devin is ahead right now and sort of stays ahead?
I think the first thing I would say, which is just kind of like a high level commentary on the space. First of all, I think there's a lot of really great teams out there and a lot of really great products. But one thing I would say is code is actually just really hard. And I mean this in both the positive and the negative, but the way I would kind of describe it is the ceiling of code is incredibly high. I think one way to say it is, if you imagine, a use case where people are doing a Q&A and it's like, hey, who was the third president of the United States, right? It was like, okay, it was Thomas Jefferson. At some point, there's not a better answer that you can give. It's just, it was Thomas Jefferson, right? Whereas I think with code, it's we kind of meme about the 10x engineer or things like that when we talk about humans, but it's true, right? There is always another level of understanding that you can have. There are harder things or more efficient things that you can build. There are better ways to build things, and I think it's one of the nice things about our space, because it just means that you can, there's so much surface here that there is real differentiation, I think, in terms of the kind of value that you can provide, right? There is always another level to push to and another kind of another tier to get to, right? In terms of how we think about things, look, I mean, I think honestly, we're big fans of most of the other products in there. I think Devin today is still rather unique in that it's this full kind of autonomous agent, right? And we've always had this view on what we think the future of software engineering looks like, and it's that I mean, as the capabilities get better and better and better, that you're going to want to do more and more tasks of this form. But I think the way that we think about what we really spike on as a team, it's we kind of invented the category, honestly. I mean, it's we believed in agents before anyone else did. There's all of this mess, as you can imagine, to figuring out these questions of how does your agent learn over time? How does your agent interact with humans? How does it insert into the workflow? How does it make the right decisions about the code base? How does it know how to use tools like the browser or Datadog or CI or whatever in order to make smarter decisions? All of these different questions. I mean, it's a very messy problem space, but it is the one space that we spend all of our time thinking about, and it's what we really care about. So,
and would you say sort of that like agentic component or focus is sort of really what defines your guys', I guess if I'm looking at like a competition quadrant, like is that really kind of what defines your guys' quadrant, which is like that agentic ability more than anything else?
Yeah, I think we've always built Devin, as a junior engineer, buddy, basically, right? And I think that's the thing that's really been most unique, I'd say, about us. I think so far there's been kind of three categories, I would say. There's been the code completion type tools or the code IDEs, and there's some great folks there. I think there's the more 0 to 1, build me a cool website type of thing. Yes. For which are mainly for non-engineers, I would say. And again, some really great companies there. And then I think there's kind of the AI software engineer, which is really the direction that we've always been building towards. So
yeah. And I'm glad you kind of sort of mentioned what are kind of like the different sort of players in the space as well. One final question I do have on this is, let's maybe take like engineers who are listening, right? And they're deciding where to take their talents, or even let's say you're not even an engineer, you're just kind of watching this whole AI thing play out, and there's these huge bets being made on sort of different players. And again, I know that sort of the pot is big enough, and the world isn't as zero sum as maybe people like to make it out to be. But at the same time, there are companies competing for talent, resources, customers, and the finish line seems seemingly the same, right? Which is, so how do you kind of like see this dynamic sort of play out? Is it that like, hey, like all these different categories are just going after different customers? Or is it that, no, we're going after the same customer, but we have a different approach? Like, how do you kind of make sense of this dynamic?
Yeah, I mean, I think we're all trying to make software more efficient in different ways, and I think that we will see overlaps or things like that over time. But with that said, yeah, I mean, I think that I think that there is so much more for the space to grow and so much more for us to do, and I think we have a pretty unique position in what we do. I think folks. It's the idea of full autonomy and agents and things like that. I think it either resonates or it doesn't with folks, and I think that's often the thing that sets us apart.
No, I appreciate that. And I also don't mean to be sort of like the podcast host trying to instigate a fight or anything, but I think it's an important question. Obviously when people look for a job, it's often the first thing they look at, right? Which is like, hey, who else is doing this kind of thing? And so that's great. I want to now kind of segue into sort of how Devin works in tech. Obviously, there's so much that's been done here, and that's really the most fascinating part behind Cognition. Yeah. To sort of set up this section, I'm curious, what do you think was the hardest problem that you guys had to solve? And feel free to get really technical on this. I know our audience digs that.
Yeah, one that comes to mind that I'll say is just the ability of Devin to learn over time, which I think is like a really, really tough nut to crack and is valuable for a lot of reasons. But perhaps the most obvious one is just, you could have somebody who's a really, really smart software engineer, built a lot of cool stuff, but if it's their first day at your company, it's going to be a tough one for them to do as much, right? Compared to somebody who's, spent 10 years at the company and wrote half the code by themselves and stuff, and I think there's a clear value diff here of like, as Devin is working with you and with your team, how does Devin continue to get more and more intelligent, right? And as you can imagine, I mean, there's a lot of, it's the kind of technical problem that kind of pulls in a lot of related problems, right? And I mean, people have this people talk about a lot of things, which I think are all pretty adjacent to this, like retrieval or context or a lot of these other things, search and so on, right? But yeah, I mean, I think that there are a lot of like really tough questions to figure out and really get into the meat of, Devin had these, let's say, 500 sessions with all of these different engineers on your team over the last month. How does Devin take the sum of all of those and everything it was taught from each of those engineers and figure out what is the best thing to do with this current task at this point in time, right?
I see. Interesting. And, solving such a problem is obviously not easy and requires a lot of talented folks. And I know this is a little bit of sort of what Cognition is sort of known for too, is your guys' talent density is probably the highest, right? And so could you speak to that a little bit? Like what are sort of the folks that are part of Cognition, share?
Yeah, no, we're very lucky to have, I think, a really incredible team, and it's we've kept it pretty small and pretty steady this entire way through. It's now about 25 people, and the way that we've always thought about these things is, I think it's kind of funny actually. The main thing I would say, of our 25 people, actually about 18 of them, I think 18 is right. 18 of us have started companies before.
Oh,
so 18 of us are former founders. This is not my first company either. And for most of the team, it's actually, people have founded their own company and got to do this. We even connected through Bryce, for example, and Bryce started his own company, right? And then came to Cognition. And yeah, that's honestly often how we think about it is, I mean, we're going after something really big. Solving all of code is the kind of thing where it is, you don't end up with a medium-sized outcome, and we're going after really the biggest thing. And I think a lot of it is, folks who are clearly good enough to do a company by themselves, but coming to work together and build something really big and really great. And over the last, it's been about 15 months now at this point. But yeah, I mean, over that time, it's been a busy one. We're in the office after midnight most days. We're doing things nonstop, basically. I mean, it's like we had a brainstorming meeting here at the office like that went past like 1 a.m. last night. And it's the kind of thing where I mean, we're all really dedicated to what we do, and I think it's a special time in AI where it's where there will be really great businesses that get built and really meaningful new paradigms that come. And that's what we want to be a part of. We want to be that, basically. We're going for it all, and a lot of it is folks who have that level of talent and also have that level of drive. A lot of our initial crew was from the international Olympiads, and so one of the stats which I kind of like to share, which is kind of funny, is on our team we have actually 20 gold medals at the International Olympiad.
Wow.
So 20 gold medals and 18 former founders basically on our team with like 25, 26 people base. But yeah, I mean, I think a lot of it is, going after this problem of, teaching an AI how to code. I mean, it's for a bunch of programming nerds like us, it is honestly the coolest possible thing that we could be working on. So.
No, and not to put you on the spot on this, and maybe you need more time to think about it, and we can kind of move on to another question. But I think something that's always kind of cool is maybe even like a little bit of showcasing. Like, are there any examples that you can think of shout out any team member of, kind of puts into perspective just the type of, talent that exists, which is, so-and-so engineer went and did this in one night, and anything like that you can share?
A lot that comes to mind, honestly, but it's the way I kind of think about it is, you going after something as big as this. I mean, I think AI code will be one of the biggest problems, I think, of our generation, and so obviously will also be one of the most competitive. But if I think about, for example, what we went into to get into this launch in December, it was on all fronts. It was just such a massive push, and so you had people like Sampriti, for example, on our team who was on Perfect Blue, which is one of the best CTF teams in the world, and he was the one driving a lot of the infra forward and figuring out how to make all the to be ready to support all the load of Devin sessions and to size things up in terms of the VMs and to handle all of this that would come in. We had people On the feature side, people like Sean, for example, who is from Harvard and worked at a few different companies, including Neuro, who's basically pulling an all-nighter, figuring out like a lot of the little product features that we really wanted to perfect and ship. And then on the go-to-market side too, it's the same story. We give it 110% everywhere. I mean, it's like Russell, who's our president. It's kind of crazy, but he was in he flew to. He flew to Madrid and back earlier this week. He had like a 36-hour trip in Madrid. The thing is, he was actually just in Paris the week before, and he had also similarly like a 36-hour trip in Paris and then back, the week before as well. And it's the kind, it's like we've gone all over the world already in just this 1 year. We've gone to South America, we've gone to Asia, we've gone to the Middle East, and it's the kind of thing where it's like. I think we've all thought about it in this way that this is happening. I mean, it is actively happening right now. It is going to be the big thing, and I think we also all have a little bit of that energy of this is going to be the big one. Like let's really treat it like that.
Yeah. That's awesome. That's really awesome. Yeah. I mean, that sounds amazing. And I want to dive in a little bit more into sort of some of like the actual tech here too. So one thing that I found kind of interesting was, Devin obviously can detect and fix its own mistakes while coding. And this is pretty huge, right? I mean, a lot of sort of software engineering is spent kind of doing that, which is you write the code, then you debug it, then you write it, then you debug it more. And then eventually you're like throwing your laptop against the wall and it's, it's terrible. But so how does Devin sort of actually do that? How does it, one, I guess maybe the more easy ball on this question is like, how does it know something went wrong? But more than that, like, what is like the verification phase? Like, what's the internal loop? How do you guys sort of achieve this?
Yeah, so there's the easy part and the hard part, I'd say. I think the easy part is basically the connectivity to all of these sources of information. Right. And so, if somebody hands you a bug, for example, it's like the ability to run the front end locally, the ability to read things in the internal wiki to understand what's going on. Obviously, you want the ability to navigate around different files of the code base or run the linter or run the tests or things like that. Right. And so that part is, I think is kind of like a bit more of like a practical engineering problem of figuring out all the tools that are needed here and really kind of like solving what do you need to be a great engineer, and what is the set of information that you need, right? I think the second problem is the harder problem, which is kind of more the brain problem, if I would describe it that way. It's kind of like there's building an AI software engineer. It actually has both parts. There's the computer and then there's the brain, right? And with the brain, I mean, I think a lot of that comes down to basically, how does Devin know how to use these tools in a way that increases its success probability, right? And so, as you can imagine, it's the kind of thing, it's like, why do we use these tools, right? Or if somebody handed you the bug, what would the process be? Maybe it'd be, okay, here's what I'm going to do. Let me go, I'm going to git pull, I'm going to get up to date, I'm going to run the code locally, I'm going to host the front end, I'm going to click around on the front end itself, and I'm going to try and reproduce the bug. And if I repro the bug, then I'll look in the logs and try to find the error. And then I'll read through the error. I'll look at those files. I'll look at documentation if I have to. I'll make some edits. And then I will go and pull up the front end again and test it and see if it now works, right? And that's like what a human would give you as kind of the reasonable process. Obviously, there's like way more detail into each of those steps and how you do each of those things. But to first, it's the reason you do those things is because your probability of successfully fixing the bug is higher if you do that than if you just YOLO it and look at the code base and just decide what you want to edit, right? And it's, no human engineer today is able to look at the entire code base and just say, all right, here's exactly what went wrong. I'm just going to give you this perfect diff and it's done, And no AI engineer really is able to either, right? And, these tools exist because the iterative process of doing this is really how you build great software, right? And so this kind of second part is really teaching it to use its tools in a way that maximizes its success probability. But as you can imagine, I mean, both of the two problems are way, there's way more complexity that goes beyond the surface. And, I call the first one the easy problem, but in reality, I mean, it's, maintaining all these VMs and figuring out how to host the infra and figuring out how to roll back state and parallelize and fork and all of the other things that you would need to do. I mean, they're both basically infinitely deep problems. So,
yeah, no, that's really insightful. I think you mentioned this before too a little bit, which is, obviously Devin is a work in progress. It works great right now, but there's also areas where it could get better as well. I'm sort of curious from your perspective, what do you think is sort of maybe the biggest bottleneck for Devin right now? Is it that the reasoning models aren't there? Is it context length is an issue and like balancing context is hard? Is it the integrations are finicky? Like what really do you think holds up Devin?
Yeah, I mean, I think Devin, and we say this all the time. Devin is basically a junior engineer today, I would say, and so it's very. I think that's kind of the right level, and I would say 6 months ago is probably like a college intern, and 12 months ago was like a high school student, high school CS student or something like that. And so yeah, it's very much junior engineer today. It's able to execute a lot of things, do a lot of things. It might not figure out like these really tough architectural questions. It might not be able to do these really massive projects all on its own. I think in terms of, what it needs, I mean, it's tough to give one answer, honestly, because there's so much of everything that still has to be done. But if I were to answer the question of, what do we think about, or in terms of like what we work on, a lot of it starts from asking the question, the other way around of, what is the future of software engineering going to be like, and how will people be building software in 5 years? And a lot of it is working backwards from that, right? And I think there's tough problems on all sides, I guess is my point. I think there's obviously like some really tough problems on the capabilities and the reasoning and teaching based, training these models that can be better and better and better. At the same time, there's also, a lot of these core questions on product experience, right? There's a lot of these questions on, how should you be working with your agent, right? How should you be giving feedback to Devin? How should you, how should you be able to follow what Devin is doing? How should Devin insert into your workflow, How should you be able to work and hand off with Devin, and how should you be able to parallelize with Devin, and all these other things? And I think the agent space is just so rich in both of these things, where there is both the capabilities of how you make all these hard decisions, but there's the entire interface of what you do. And I think those are kind of the two big categories, I would say, of things that we work on. So
I guess a little bit more on that though would be like, I'm almost curious, like, if we were to see like, let's say this was like a finite amount of hours that it took to build Devin, right? Like, how much of the team's time do you think is sort of dedicated towards like getting the module for like task planning versus like, is it trying to figure out like, okay, like we have access to this person's code repo, we need to ingest all of this into context? Or is it like you guys spend a lot of your time like, spinning up the VM and making sure the integrations are working? Like, or is it kind of equally split? Like, I'm just kind of curious, like, if you're an engineer on Cognition, where is sort of like a lot of the energy being diverted?
We have a few pods each week is how we're typically, I mean, there's like 3 or 4 pods, and it often rotates week to week who's in what pods or what pods are doing what or whatever. And so everyone does a little bit of everything, but I think at a high level, I would say that I think if I had to pick one, I think that, the biggest thing that we really focus on is what I would call kind of like, like the brain side of thinking about, teaching Devin the right capabilities and giving Devin the level of intelligence that it needs to solve tasks. I think with that said, it's, honestly, it's all pretty close. We spend a lot of time thinking about the infra and all of the actual detail that goes into, making Devin basically. And then we also spend a lot of time thinking about the core product interface. But it's, yeah,
that makes complete sense. Yeah, it is. So it doesn't seem like there's like maybe like one glaring bottleneck or something, which is like everything's there, but just the integrations are finicky. But okay, that makes sense. I guess just 2 more quick questions for you, which I find to be pretty interesting. I think it was at a Microsoft talk that you were giving, in which you kind of had this slide that showed that there's almost this entire ecosystem that powers Devin, right? Which is people sort of see the brain of Devin and the planner and kind of stop there. But, there's a lot more that goes into it, right? Which is like the integrations and the memory, the embeddings, all that good stuff, right? Obviously, in order to power Devin, you have to build a lot of that in-house, I assume. But from this like ecosystem that agentic products can use, what do you think is still like glaringly missing? Like, where do you wish developers were maybe diverting more energy towards to building solutions that would greatly help Devin and, maybe other tools are in this agentic code space?
I'll give you a kind of different answer actually, which is that you often have to be so opinionated about these things that it does just kind of make sense for us to build these in-house. I think there are folks for a lot of these actually that have built many of their own solutions and things like that. And I think there are different categories of agents. I think for kind of a lot of these like, plug and play agents that folks will want to be able to build and spin up quickly or things like that. Like I think people find value with those tools. I think for us, it's very, we just want to have such tight control over, what the action space is, for example, or how Devin learns over time, or how we pull in the right, files into context, or any of these things like that, right? It's like, all of these things are kind of the meat of what makes Devin special, right? And so it's an interesting one, but I think to some extent, yeah, we kind of have to own those ourselves and build a lot of those ourselves. Yeah.
Yeah, that's a really fair answer. Yeah, that's awesome. I guess the second question I sort of have here too is, you touched upon this briefly. You've also touched upon this, I think, in other sort of interviews or you've done in the past as well. But you've said that like there's like a very interesting UX and sort of product challenge here as well, which is like, how do you interact with this product, or how do you interact with this agent? And I think it's really interesting because I think a lot of people don't realize how much like that UX almost sometimes even like shapes the actual like tech that goes behind it and the feedback loop with it. So like, how do you sort of think of that? And do you think you've cracked this?
So we have not cracked this, I would say. But I think the way that I kind of think about it is, the precursor to agents, I would say, is chatbots, right? And chatbots are the natural thing that folks think to when they're thinking about agents. But the thing is, chatbots are so much more simple, right? And they're, at this point, I think people generally know how to use a chatbot. You ask a question, you get an answer. You ask a question, you get an answer, right? And it could be a customer support chatbot, it could be a Q&A thing, it could be a search thing, and you still kind of have the same general scaffolding on this is how you work with your chatbot, right? I think with agents, it's actually quite different because the whole point of an agent is to actually do things and take actions in a real world environment, right? And what that means is the set of actions that you need to take, or the set of things that you need to slot into and interface with, is actually just very different for every product, And so we see that all the time with Devin. It's obviously, Devin's plugged into your GitHub. Perhaps that's the most obvious one, right? And so Devin can, make a PR and you can comment on Devin's PR and Devin will see it and things like that. But at the same time, there's all of these other things where, for example, if you're working with Devin, there's a super clean way to get into Devin's VS Code and understand exactly what's going on. There's a super clean way to see what shell commands Devin is running. There's a super clean way to see Devin's browser. You can tag Devin on an issue that you're talking about in Slack, or, a lot of things here which are specific to software engineering, right? Or you can SSH into Devin's machine if you want to, run something or do some stuff in Devin's machine. And so these are all actually much more bespoke, right? They're very software specific, And I think what we'll start to see actually over the coming months is this kind of like proliferation of vertical specific agents, if that makes sense. If you're building a legal agent, it's certainly not VS Code and GitHub or whatever. There's this whole other set of things that you want your tool to have access to, and you want you want it to be able to use, and ways that you want it to slot into your workflow and so on, right? And so we find ourselves thinking about these questions all the time. I think the interface of up until now obviously has been the IDE, right? Which is kind of the way to see your code and to understand what's going on and to run stuff and make edits. I think with agents, it's actually a whole new paradigm, I think, where you will want some of those things as well. And, obviously you want to be able to read files, edit files, or whatever in the same way, but there's all these other things that you'll need to think about as well, right? And these other tools that you want to interface with respect to that. So.
Yeah, that's super exciting. And just a quick one, because you mentioned this, but, is there a lot of focus also in terms of like guardrails? If you are giving all this access, how do you sort of ensure that, Devin doesn't go off the rails and then he starts doing things that it shouldn't be doing, right? Like maybe you don't trust an intern pushing the prod, right? Like,
yeah. So as always, it's human plus machine, doing things better with the combination, right? And so, there's a lot of the simple ones here, which is Devin will never push straight to master or never push straight to prod or things like that. The way that it interacts is it sets up its own branch and then it makes a PR, and you are the one who reviews the PR and decides whether to merge the PR. Similarly, a lot of these things with access, obviously, we have set up very tightly, so it's only able to use certain accesses for certain things and so on. But yeah, it's kind of a funny one because I think especially as you start to get into somewhat larger orgs, folks have had to think about this to some extent already, right? It's if you're at a 10,000 person company or 100,000 100,000 person company, I mean, you can't just give every single person access to product, right? And so a lot of it is having Devin slot into those same models.
That makes sense. Well, Scott, you have already been so gracious with your time, and we appreciate you coming in. For those who have not checked out Devin, absolutely check it out. And for engineers who are interested in working at Devin and Cognition, where would be the best place for them to reach you? Would it be on your website, someone directly?
Yeah, so we're at devin.ai. If you'd like to try it out or read more about us, and then shoot me an email at scott@cognition.ai if you'd be interested in talking more.
Perfect. Well, thank you so much.